solving exponential and logarithmic equations. And all we're going to do today is practice solving for x when we have logarithms. So, first of all, I'm going to show you guys, I don't know, there's like 11 examples or something. And I think the best way to show you guys this is just to show you examples. So, ln of x minus the ln of 11 equals 0. What would this x value have to be? What would that x value have to be in order to get an answer of 0? The ln of what number minus the ln of 11 would get 0. Yeah. So that's kind of like this is a no-brainer here. So some of these things will be simple. Don't put too much thinking into all of them. Yes?
You can change colors to like a bright green.
Yes, I can change colors. Let's got a note.
Red.
Red.
Go red.
No blue this time.
Dark red.
No
To
blue.
that top left corner.
Crimson.
Yeah, that's
We're spending too much time worrying about color right now.
You
Okay.
do blue too much.
E, but it just works so, it's easy to see, and people have no problems reading it. And all right, e to the x power equals 13. All right, I don't know what power you can put e to that will get you 13, but I do know that this is an exponential form. So in order to figure out what the x is, we're going to have to undo exponential form, which means we're going to have to change it to logarithmic form. So we need to take this exponential and we need to change it to logarithmic form. So e to the x power equals 13. I am going to change that to a logarithm, and what becomes my base value? Wow, okay, this number right here, it's the base in exponential form. It remains the base in logarithmic form. So this is going to be log
13.
base e of
13.
13, and then it's always going to be equal to the power. So we have log base e of 13 is equal to x. What does log base e mean? It means ln. Alright, so now I'm going to write this as the ln of x. No, the ln of 13, excuse me. ln of 13 is equal to x. Calculator problem, type it in. What is the ln? What is the natural log of 13? Say it again. 2 point. Okay, so we'll say just 2.56 is good. 2.56. Alright. Third example.
This is easy.
This is, yes, it is. Enjoy it. They'll get harder. Come on, Richard.
See what you did.
All right. Log base 8 of x is equal to 4. Right now, this is in logarithmic form. And I don't know how to figure out what is the value of x that would make this logarithm equal to 4. So whenever in doubt, and it's in logarithmic form, change it so that it is in exponential form. Yes. So I'm going to take this logarithm, log base 8 of x is equal to 4. I'm going to change it so that it is in exponential form. So what am I going to do?
Make 8. And then to the power of 4.
4. 8 to the power of 4. Remember, this 8 has to
Equal
stay
x.
the base value. 8 to the power of 4 is equal to
X.
x. What is 8 to the 4th power? That means 8 times 8 times 8 times 8. 4,096. Thank you. So x is equal to, yes,
96.
not so bad, right? ln of x is equal to 20. Now, if this had said ln of 20 equals x, that would be easy. You could just type in ln of 20 and get an answer. But here we have the ln of some number is equal to 20. So what I'm going to do with that natural log is change it so that it has a base value. How can I change the ln so that it actually has a base value? What is ln the same thing as?
Log.
Log base e. So I'm going to change this to log base e of x is equal to 20. Now what do I do? Yeah. Oh yeah. What am I going to do now? It's a logarithm and I don't know how to solve it, so you're going to change it so that it is in
Exponential form.
Make e your base with the exponent of 20 equals x.
yes.
Then you get a negative number.
I knew it, my boy. Libra.
Yes. Change it so that it is e. Now this is going to get you such a gigantic number, like so big, that I wouldn't even bother writing it down. What I would do instead is leave your answer as e to the 20th power. Let's call it that. If you want to write down, I think the actual value is 485,165,195.4-ish.
Yep.
Somewhere, yeah, I did that all in my head just a minute ago.
Okay.
Oh,
That's hilarious.
Not get ahead of yourself, Mama Square. Take a step back. Step down the top floor real quick.
So,
I did that over here real quick.
I'm okay. If the numbers are so gigantic, just leave it like that. E to the 20th power, okay?
Yep.
Alright, number 5. Alright, I want to explain, it might be helpful for you guys to write what I'm going to write down first. It might be helpful to do this first, but you might want to hold off on what I'm going to write first to decide if you think that's something that you need to write down. We have 5 times e to the 2x minus 3 power equals 12. And what I want to do is just take you back to Algebra 1 here for a minute. What if this had said 5 times x equals 12? In other words, this e to the 2x minus 3 power is that's the part we don't, that's what's kind of screwing us up. We don't really know what that means or what that is. So what if it said 5x equals 12? What would I do to figure out what x is? You would divide by 5. So I divide by 5 on both sides, so x is equal to 12/5. X equals 12/5. So, and then I would be, if it was Algebra 1, we'd be done. But this is pre-calc, so of course we're going to make it a little bit harder. But I wanted to talk to you about this problem like this, because the first thing that I suggest doing is getting rid of that 5 out front. It says 5 times e to the 2x minus 3 power. So what we're going to do first is divide by 5. Just like we would if this was just a basic algebraic equation. You would divide by 5 first. So we have e to the power of 2x minus 3 is equal to 12/5. Now if you want to change 12/5 to a decimal, I'm going to leave it just like this. Right now we have an exponential situation, and I don't know how to figure out what the x value is. So whenever in doubt, if it's in exponential form and you can't figure it out, what do you need to do?
Change it to log.
Yeah, change it to logarithmic form. So I'm going to change this exponential situation to a logarithmic situation. So this becomes log base e. Remember, the base value has to stay in e. Log base e of what?
12 5.
12/5. 12 over 5 is equal to
2x
the power,
minus 3.
which is 2x minus 3. Alright, what does log base e mean? It's ln. So I'm going to rewrite this now as the ln of 12/5 is equal to 2x minus 3. Guys, we're trying to figure out what x is. What do I do to figure out what x is?
Divided by 2.
Add 3. Yep, add 3 and then divide by 2. So I'm going to add 3 to this side and I'm going to add 3 to this side. Awkward, yes. So make sure when you are typing this into your calculator that you are taking the ln of only 12/5. The ln of 12/5. Finish off your parenthesis. Okay? You alright with that? You're only taking the ln of 12/5. And then you have to add 3 to it. equal to 2x. I don't want 2x, I only want x. So what do I do to figure out what x is? Divide by 2. Yeah, I divide this side by 2. So I divide by 2 on the right, which means I have to divide by 2 on the right. On the left, excuse me. Divide by 2 on the right, divide by 2. Sorry, I'm having
Okay,
issues
Miss
with
Porter.
left and right today, okay? So we have the ln of 12 divided by 5, close off your parenthesis, plus 3. Get an answer.
1.39.
And then divide your answer by 2. Make sure you have completely computed to the top before you... Make sure you have completely calculated the top before you divide by 2. You guys are
Completely
brutal.
computed.
Horrible. Alright, so x is equal to, I don't know what you get, you guys. 1.938, 1.94. I just did that in my head too.
Because you computed it, right?
Right. So number 6, if this was a basic algebraic equation such as, can I erase, first of all, can I erase number 5? Is everybody down with number 5? Can I erase?
No.
Yeah.
Speak. Okay. Number 6. I'm going to leave it up there. Number 6, think of it like this. Think of it as 6x minus 5 is equal to 27. What would you do first to solve this algebraic?
Add 5.
You would add 5, and then you would
Divide by 6.
divide by 6. So I would go plus 5, so we have 6x is equal to 27 plus 5, which is 32, and then you would divide by 6, right? So x would be equal to 32 divided by 6, which is 16 thirds. But we're not in Algebra 1, we're in pre-calc, so we gotta make this a little bit harder. But you're still gonna do the same thing. What do you do first to solve for x? Add 5. Yep. I'm gonna delete now. I'm gonna add 5 first. So I have 6e to the power of 4x plus 3 is equal to 27 plus 5 is, again, 32. And then what do? Just like if it was algebra, I would divide by 6. So I divide the left side by 6. I divide the right side by 6. So we have e to the power of 4x plus 3 is equal to, and you can leave it as 32, 6. In fact, I think I will just for the sake of this conversation. We're not going to reduce. We don't have to reduce. The calculator will still find the right answer for us. All right, we have e to the power of 4x plus 3. It's an exponential form. We don't want it in exponential form. We want it in logarithmic form. So we're going to change this so that it is log base e of 32 over 6 is equal to the power, which is 4x plus 3. Log base e. What does log base e mean?
ln.
Means ln. So I'm going to rewrite this as the ln of 32 over 6 is equal to 4x plus 3. Now we're at a pretty basic algebraic equation. Even though this ln makes it look more confusing, remember the ln of some value is just a number. It's going to be a crazy irrational number, but it's still a number. So the next thing we would do is subtract 3 from the right. We subtract 3 from the left. So we have the ln of 32 divided by 6 minus 3. Make sure you close off your parentheses when you do the ln of 32 divided by 6. Subtract 3 equals 4x. Divide both sides by 4. And because I am a human walking calculator, I believe that the answer is negative 0.33.
Yep. You got it, Miss Corbin.
I did?
It's almost as if you did the problem.
I know, it's almost as if I already had it worked out, which I didn't. So, how is this? Does it seem horrible?
I'm tired.
No.
But it's good. It's good.
could add 7. So add 7 first. So I add 7 to the left, I add it to the right, so I have 5 times 6 to the 2x plus 1 power is equal to 15 plus 7, which is 22. I'm going to divide both sides by 5. So I have 6 to the 2x plus 1 power is equal to, I'm going to leave it as 22 fifths. Did I go, am I going too fast?
A little.
I'll stop. I think what I've done so far is nothing crazy, but that's just basic algebra. I'll give you guys a chance to catch up. It's in exponential form,
We put it in logarithmic form.
so we
right?
want to put it in logarithmic form, yes. We don't have an e in this one. We've had a lot with e's in it. We do not have an e in this one, but that's okay.
Just
We're going to change
base
this
6.
so that it is log, what's the base value? 6. Log base 6 of that number of 22 fifths is equal to the power, which is 2x plus 1. All right, this is an issue. This right here used to say, I think most of the examples we've done, we would have log base e, which we just quickly changed to the ln. What does this mean to you? What do you have to do when you have a logarithm that has an uncommon base? In other words, not a base 10 and not a natural logarithm. Yes?
Do the log of the 22 divided by 5 over the log of
Yes. What's that called?
changing base.
Change of base formula, yeah. So we're going to do log of 22 fifths. Make sure you close off your parentheses. Get an answer. Divide that answer by the log of 6. And that's going to be equal to 2x plus 1. And I'm completely running out of room. That's okay. All right, so you're going to get an answer over here. You're going to get some crazy decimal answer. And whatever you get for that answer, what are you going to do to it? That crazy decimal answer, it's still a number,
Subtract.
is going to be equal, it's equal to 2x plus 1. How do you solve for x over on the right-hand side of this?
Subtract 1.
Subtract 1. All right, so you subtract 1 from the right, you subtract 1 from the left. So you have the log of 22 fifths divided by the log of 6 minus 1 is equal to 2x
Divided by 2.
divided by 2. Yeah, so now we're going to take this, we're going to divide it by 2.
I was doing it right.
So my suggestion when you're working on this is a long one. Do this. Do the log of 22 fifths divided by the log of 6. Get an answer to it. Press enter, have an answer. Subtract 1 from it. Get an answer. Make sure you have an actual answer calculated on your calculator, and then divide it by 2. And then that's going to be your final answer. And I'm going to take a ballpark guess that you're probably going to get an answer around negative 0.09.
Oh my goodness. You hit it.
You hit it.
Negative 0.09.
16 seconds.
So make sure every single part of this is done. Get an answer after each part.
It's negative 0.09?
Negative 0.09. That's what I did when I did it in my head.
Okay.
I think it is.
Yeah,
When I
you're
did it in
fine.
my head, I think that's what I got.
She's not sure. Could be.
Do you guys agree with my answer?
Probably.
All right, so did you do log of, in parentheses, 22 fifths?
Yeah.
Enter.
Yeah.
Divided by log 6. Okay, and you press enter. Minus 1. Enter. And then divide by 2.
Get your minus 1, then divide by 2.
Yes.
Does that make a difference? Or divide by 2 and then minus 1?
Oh, that makes a huge difference, yeah. Yeah, make sure you guys subtract the 1 first. Anything else that I can clear up there?
Oh, that different. Oh.
That was a
I got-
long example.
It was a long example.
86. So you round it, right?
What'd you say?
I got negative .086.
Yeah.
Okay,
Yeah.
round it. All right.
Actually, didn't you get something even longer than that?
Yeah. It's,
Yes. Yeah.
all right. All right.
Okay, number 8. Number 8 is an easy example.
Dang, it really is. Is it 'cause that's
Here we have log base 4 of something equals log base 4 of something. Well, if these two things are equal to each other and they're both logarithms and they have the same base value, it means that this has to be equal to that. So you put them equal to each other and you solve for x. So you have 6x minus 8 is equal to 4x minus 14. That's an algebraic equation that all of you should be very, very good at. I'm going to move the 4x over first of all, subtract 4x. 6x minus 4x is 2x minus 8 is equal to negative 14. I know I'm going fast, but I feel like the algebra here is pretty straightforward. 2x is equal to negative 14 plus 8, which is negative 6. And then I divide both sides by 2. So x is equal to negative 6 divided by 2, which is
Negative 3.
negative 3.
Ha.
Not bad, right?
Easy.
Not at all.
No.
Easy peasy. My boy can fall asleep.
Okay, number 9. Yes.
This next one long, must be at the bottom of the page.
Probably not.
Probably not.
Your friends always laugh when
Oh, there's a wasn't exact.
How many examples do we have?
I don't know. I'm kind of thinking we might even, if you guys want to stop right now, I kind of feel like we've probably done enough.
Yeah.
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 I mean, if you
brain
want to
is
write
fried.
these down and try them, you can. But I kind of looking at these going, you know what? I'm thinking
They're all similar, so.
they are all very,
Wait,
very
can
similar.
we do
so-
10?
Yeah, can we do 10?
Yep, let's do number 10.
Just
We'll do number 10 and then call it good.
Yeah.
All right.
Hold on.
Number 10. All right. Let's just say for a moment that this said this. It said 12 minus 3x equals 8. What would you do? Subtract 12. Yep, you would subtract 12 first. Subtract 12 over here, so we'd have negative 3x is equal to 8 minus
And
12 is negative 4. And then you would divide by negative 3, so x would be equal to a positive 4/3?
Yep.
Alright, so we're going to treat this the same way. What are we going to do first to solve for x in that?
Subtract.
Subtract 12. Alright, so I subtract 12, same process here. So I have negative 3 ln of x is equal to negative 4. I divide by negative 3 on the left. I divide by negative 3 on the right. So I have the ln of x is equal to negative 4 divided by negative 3, which is 4/3. The ln of what number is 4/3? I don't know. So what are you going to do?
I thought you knew.
You put,
Oh, wait, I do know, yes. Yeah, go ahead, Marcus.
you put e to the exponent of 4/3.
Yeah, so I'm going to change the ln to be log base e. Log base e of x is equal to 4/3. So to figure out what x is, I take this base value and I put it to the 4/3 power, and that's going to get me my x. So I have e to the 4/3 power is equal to x. And I got about 3.79.
3.8.
3.7. Yep.
Okay.
Got it. Cool.
Can we do 11?
No.